Hi, everybody. We're back with more game theory. Today, we're going to talk about dominance, okay? And this is when one strategy that a player has dominates another. That means it's strictly better, all right? So, the definition is that strategy S dominates strategy T if for every single entry in S, it's greater than or equal to the corresponding entry in T. Okay, and at least one of them is going to have to be better, right? If all the outcomes are equal, we just have the same strategy. S is equal to T. So for S to be a dominant strategy, at least one of the entries has to be strictly better than the corresponding entry in T, and all the others have to be at least as good. Okay? And by the way, we're just going to use greater than or equal to mean dominated when we're talking about strategies, right? So these will be capital letters. And then also, you have to remember that Colin is minimizing. So a Colin dominated strategy is the opposite, right? It's less than or equal to, but we'll get to that, all right? Um, so look at the 2x3 game below, right? With Rose and with Colin. And by the way, Rose doesn't have any dominance. Why? Well, look, here we would go down to get the large, oh, but we go up to get the larger value, then we go down, right? So from Rose's perspective, there isn't dominance. There's not one strategy that's going to be at least as good or better in every case, right? Um, so let's look at Colin, all right? So one thing that we notice right away with Colin is that, hey, strategy A looks pretty good. Why? Remember, Colin is minimizing. And if you're minimizing, 0 and -1 are pretty good values, right? Oh, and let's notice that -1 is less than 6. 0 is less than 4. So we know that Colin A dominates Colin B. And oh, -1 is less than +1, and 0 is less than 10. So we see that column A is also dominating column C. So column A is the best of the three. And by the way, when this is the case, right, remember the rational play principle, right? Colin knows that these are dominated. So we can kind of just get rid of them. Why? Because he'll never play them, right? There's no point in having them in the game if Colin will never play them. So the rational play principle allows us to reduce by dominance. All right, and in this case, we get to reduce two strategies. And when we're only left with the one strategy that Colin will play, we can see, oh, Rose would pick strategy B because that earns one more point than strategy A for her, given that Colin only plays A. So it turns out that if there's a pure strategy solution, we can often get there by reducing by dominance. Okay, there are other ways to get there, but that is one good way. So So example one, solve the game using reduction by dominance. And let's first notice, I mean, I just always start with rows and rows. Okay, 7 is greater than -4, but 10 is not greater than 11, right? So I don't have rows A dominating rows B. And yeah, the problem is, right, that the larger of the two values is up in the first case and down in the second, right? We're going in opposite directions. So Rose doesn't have dominance. Okay, but let's check for Colin dominance. Oh, nice, nice, because 7 is less than 10 and -4 is less than 11, right? So what do we have? Well, we have this in our notebook, so let's jump over there. Okay. And what am I going to do? First, I'm going to switch from code into Markdown. Why? Because I'm going to say that, first of all, let's say, right, it is colon A dominates colon B. Why? Well, first, here, let me actually, let's use bullet points, right? So I'm going to go, um, let's go 1. No, let's use the bullet points. So I'm doing a minus sign or dash. Um, The first thing is that I'm using dollar signs, so this is going to switch me into math mode. So 7 is, and I'm going to use less than or equal to, so backslash LEQ 10. And then the second thing that I'm going to put is that -4 is less than or equal to 11. And when I run that, we can see, okay, we've done the math showing this, right? And we will just say, thus, and I'm going to use, let's see, what am I going to use? Thus, for Colin, A is less or equal to, right? Less or equal to B, close the dollar sign mathematics. And there you go. Colin A dominates column B. Remember, Colin is trying to minimize, so we use the less than or equal to. All right. So I'm going to save that, and again, you'll get your checkpoint created notification. It's off my screen, right, that I'm recording, but you'll see it if you hit Control S. Okay. And again, the key is always to remember when I'm doing Colin, remember that Colin is minimizing. When I have the condensed version of the zero-sum game, Colin is minimizing, not maximizing, which is an easy thing to forget. So just remember that and be careful. And so let's first check for Rose dominance. And the key thing to notice is that the first two strategies that Rose has, A and B, they start off the same way. Okay, so if C and D, if we can get lucky there, one of these dominates the other, right? And you notice that -2 is less than -4 and 1 is less than 5. Oh, so A is less than or equal to B, so B dominates A, if that makes sense. And let me get the numbers uncovered so you can see that again, right? So 8 is greater than or equal to 8, 7 is greater than or equal to 7, 4 is greater than or equal to -2, 5 is greater than or equal to 1, right? So what does that mean for us? That means that Rose B dominates Rose A, which means we can eliminate it. Remember, we're doing reduction by dominance here. And since Rose will never play A, we can just get rid of it. We can just cross it off, right? And one thing that we do just to keep from going insane, trust me, with these large games and we reduce a few times by dominance, it starts to get real messy if I just cross out the row. So rewriting the game isn't terribly bad, so let's do it. And what do we find out? Well, we no longer have Rose dominance, right? Because 8 is greater than 0 and 7 is greater than -2, but oops, 4 is not greater than 12. So Colin C is kind of messing us up from getting any more Rose dominance, but we have Colin dominance. Why? Well, let's find a good Colin choice here. And there are a couple that will dominate A, right? But let's just do the one right next to it. B dominates A. Why? Well, because 7 is less than 8 and -2 is less than 0. Notice that D also dominates A if you think about it. But what does this mean? This means we can get rid of Colin A. It's dominated, right? And what about B? Does it dominate C? No. 7 is greater than 4, but -2 is not greater than 12. Does B dominate D or D dominate B? No, neither one. Why? Because 7 is greater than 5, but -2 is less than -1, so we don't have any dominance there. 7 is greater than 4, but -2 is not greater than 12. 4 is less than 5, but 12 is not less than -1. So looking at all the pairwise comparisons, we don't have any more dominance for Colin. But notice, we started with a 3 by 4 game matrix, and we're down to a 2 by 3. We've eliminated by dominance, we've reduced and gotten rid of one row and one column. Okay, so this is a simpler game. It may not seem like we've made a lot of progress, but soon you'll know how to solve that one. All right, so we have made progress, but we don't always have a pure strategy solution, and sometimes the game doesn't reduce all the way to a pure strategy solution by dominance, okay? Example 3, check first for rows dominance, and I hope it's clear just by scanning right that there's a lot of big numbers in rows B, and remember rows is trying to maximize. So notice that 8 is greater than 3, 11 is greater than negative 2, 12 is greater than anything negative, 12 is greater than anything negative, right? So that means rows B dominates rows C, and we can just eliminate C. But rows B dominates rows A, right? 8 is greater than 7, and 11 is greater than negative 1, 12 is greater than 5, 12 is greater than negative 3, right? So B not only dominates C, B dominates A. And I think you're picking up a pattern. 8 is greater than negative 3, 11 is greater than 10, 12 is greater than 3, and 12 is greater than 9. Yep. So it turns out that rows B dominates 3 rows, leaving us with a 1 by 4 game matrix. Remember, Colin is minimizing, so we can see right from the get, he's minimizing and the smallest number in the row is 8. All right, so, right, the solution to this game is going to be, hey, rows will always choose strategy B. Why? Well, it dominates her other 3 strategies. And since Colin is perfectly rational, and his self-interest is to minimize, right? Colin will always choose the smallest value. And since Rose is always choosing B, the smallest value in row B is when Colin plays A. So the solution to the game, it is a pure strategy solution. And Rose will always play B, Colin will always play A. All right, so getting the scribbles out the way. Notice that we don't necessarily have to check for Rose dominance first. I tend to. Why? Well, because Rose is maximizing, it's easy to kind of think of dominance for me, my brain thinks of dominance in terms of the big numbers. So I tend to look for Rose dominance first. And then Colin minimizing, it takes my brain a little, a couple of seconds to wrap my mind around that. But you can check for Colin dominance first. If you find any dominance at all, you get to reduce. You get to eliminate the strategy that's dominated because of the rational play principle that we talked about last time. Okay, so let's jump into the notebook because there's a couple more examples we get to do here. And let me scroll down. So we're going to solve the game using reduction by dominance. Now we looked at this one before, right? And we have 8, 7, 4, 5 in rows B, which dominates rows A. Okay, and let me just show you a trick here. When we're in the notebook, I can double click on this, and this is my game matrix, right? And I can copy it here and turn this into Markdown. And why am I doing that? Let's just go run. Well, because we have dominance, which means what? Which means I can get rid of row A. How do I get rid of row A? Row A is right here in the code, and I just eliminate it. Okay, so now, right, I get to work on these, right? And with 7 less than 8, negative 2 less than 8, I get to get rid of A. And again, I will just show that happening, right? I come in here, how do I get rid of A? Well, first thing I have to do is get rid of it in the titles. And then I have to get rid of it. It's the first one here. and the first one here. And when I run this one, you can see that I'm just left with this part of the matrix. You can see I've got these 6 entries. Why? Because rows A was dominated by rows B and it's gone, and then column A was dominated by column B and it's gone. So I'm left with these 6 entries, which you can see here. And as we said in the PowerPoint, it does not reduce further. This is reduction by dominance. I have a simpler game, but there's some work to do. And the main issue here is that it's not a pure strategy solution. The main difficulty is this is going to be an MSS, a mixed strategy solution, where more than one strategy is active and gets played. Okay, so last but not least, and this is the one where we realized, hey, the good strategy is rows B, which dominated. Rows B dominated A, C, and D. We found that out. And we found out, right, that since Colin is minimizing, the correct answer is that Rose will always play B, and therefore Colin will always play A due to the rational play principle. So this is reduction by dominance, and sometimes we solve all the way, and that works often when we have a pure strategy solution. In example 2 in the notebook, it didn't work. Why? Because we end up having a mixed strategy solution, and for a pure strategy solution, each of the players, all but one strategy, goes away in the reduction process. But when there's a mixed strategy solution, there's more than one active strategy in the final analysis, so we can't get all the way down to a single value for the game. But here the value of the game is 8, and the correct answer is Rose will always play B and Colin will always play A. All right, so now we're actually doing some mathematics with game theory, and reduction by dominance is something you should definitely work on. It will recur. We'll see it again. Thanks a lot. I'll talk to you next time about equal expected value and equalized expectations.